That's not what I want to do either. We'll go with it, and then I'll copy and paste it over to my files. All right, I have a little bit of right. We'll eventually get over this. A couple of housekeeping things to do this morning before I start finishing up chapter 6. Had quite a few questions on this particular problem. And then I had some questions on finding the z-score given the probability, which we hadn't gone over yet. Which is okay. We'll do that this morning. But this problem, I am huge about drawing pictures of what we're doing. So I believe that if you're going to find the probability, you should draw a picture of your normal distribution before you go to your calculator and calculate the probability. That's my belief. So what does this say? Find the probability that Z is less than negative 2.37 union. And if you recall, which many of you do not, that union means or. It's this or this. So or Z is greater than negative 0.27. So I'm going to draw, we're talking about z-scores. So I'm going to draw the standard normal distribution. Standard normal distribution has a mean of 0 and a standard deviation of 1. And we're looking for the probability, the area under the curve, that Z is less than negative 2.37, which would be over here somewhere. Negative numbers are to the left of 0 on the number line. So the probability that a z-score would take on a value less than negative 2.37 is the area I shaded. Now, what's the probability it's greater than negative 0.27? Well, negative 0.27 would be over here somewhere. I'm sorry. Greater than would be the area to the right. And what your calculator finds is those areas. That is what it's finding. Area is probability. So to find the probability that Z is less than negative 2.37 or it's greater than negative 0.27, we're going to add those two probabilities together. So the probability that Z is less than negative 0.237 or greater than negative 0.27 is the probability that Z is less than negative 2.37 plus the probability that it's greater than negative 0.27. Okay, so now I'm going to do this on my calculator. All right, so to find the probability that Z is less than negative 2.37, I'm going to use the cumulative normal distribution. So I'm going to go second distribution, and I'm going to do number 2. And the distribution defaults to the standard normal. It defaults to finding the areas under the curve for Z's. And how do I know it defaults to the standard normal? Because the mean is 0 and the standard deviation is 1. So I'm now going to put the lower limit in for Z is less than negative 2.37. So the lower limit is going to be as far left as I possibly can go. So I'm going to do a really small negative number. So I'm going to put in negative 1 to the 90, negative to the 99, So that's -1 times 10 to the 99. Really, really negative number. Okay, my upper limit's what? -2.37. And then I'm going to use that mean as standard deviation because it's standard normal. And then paste that back into my home screen. Now I'm going to add to that the probability that Z is greater than -0.27. So now I'm going to start at -0.27 and go to the right. So I'm going to go back to my distributions. I'm going to go to my normal distribution number 2. And now my lower limit is -0.27. And my upper limit, I'm going to put a really big number in there. So 1 times 10 to the 99. Okay, so now we're going to paste that in. And I get 0.6153138. So the probability that I get a Z-score purely at random less than -2.37 or greater than -0.27 is 0.6153. So back in the day, we had these called Z-table. And the Z-table gives you areas to the left of a particular Z-score. So if I want to find the probability that Z is less than -2.37, I go in my Z-table and find -2.37 right there. The area under the curve to the left of -2.37 is 0.0089. And this only gives you areas to the left. So to find the area to the right, I find the area to the left and subtract it from 1. So -0.27. See if I can do it. Will it let me scroll up? It will. That's kind of cool. -0.27, I think is right there. So the area under the curve to the left of -0.27 is 0.39. So to the right is 0.61. And you add that to the other area we got and you get the area under the curve. So when I talked about the tables, that's what these are. And guess what? This is QR. In my quantitative reasoning class, I don't require them to buy this calculator. So they have to use tables to find the areas under curves. Okay, the next question I got, which I haven't answered yet, because we're going to go over this in class. All right, what if they give you the area under the curve? How do you find the Z-score? So what is C if the probability is 0.3? If you have C as less than some constant C. So what they've given you, since they've given you the probability, they have given you the area under the curve. I have to draw a picture. So I have a standard normal distribution, because we're talking about Z-scores. The mean is 0, standard deviation is 1. And I have some C where the area to the left of that value of C, the area under the curve, is 0.3. Now, how do I know that it's over there and not over here somewhere? How do I know it's over here to the left of the mean? Well, I know that because if the area under the curve is probability and the total area under any continuous probability distribution curve is 1, then to the left, excuse me, to the right of 0 and to the left of 0, I have to have exactly 1/2. So the area under the curve to the right of 0 is 1/2. The area under the curve to the left of 0 is equal to 1/2. So if the area is somewhere 0.3, then it has to be over here to the left. All right, okay, that's all well and good. How do I figure out what C value corresponds to an area under the curve of 0.3? Well, back in the day, you went to the table until you found a number close to 0.3, because these are all areas under the curve. So it looks to be somewhere close to negative 0.5. Okay, but with a calculator, we're going to use what is called the inverse normal. So again, if I go to my distribution menu, I have number 3, which is inverse normal. And the inverse normal will give me the z-score for a particular area under the curve. So I'm going to click on that. And what does it ask me? It asks me for the area under the curve and the mean and standard deviation. So since this is a standard normal distribution, we're talking about z-scores. The mean is 0 and standard deviation is 1. And what's the area under the curve? 0.3. Paste that back in. Negative 0.5, is that what I saw from the table?
How would I find my inverse normal again?
What's that?
The inverse normal, how do you find it again?
It's going to be your distribution menu, second, variables, It is number 3.
Okay.
I think that's what my table told me, wasn't it? Negative 0.5. Negative 0.5. So the area under the curve equal to 0.3 equates to a z-score of negative 0.5. I was telling my algebra class this morning, one of the coolest things about mathematics is it's so predictable. We were doing polynomial functions, and it's all predictable. It all follows a pattern, which is kind of cool. Unlike a lot of things in life, math is fairly predictable. Okay, let's keep going. All right, so we did this one, an example just a minute ago. So this is an example that we had. It's one of your homework problems, the union. And to find the union of two probabilities, and you're going to add those two probabilities together. Get to my notes here. Let you paint dry. All right, so to find the probability, I have to draw a picture. Mean of 0, standard deviation of 1, less than negative 1.72 would be over here, and greater than 1.85 would be over here. So to find the probability of z being less than negative 1.72 or greater than 1.85, we're going to add those together. All right, so I'm going to go to my calculator and I'm going to do a normal. CDF for -1 times 10 to the 99, -1.72, 0, 1. So we're gonna look at from negative, as far as negative as we can get, to -1.72. And then we're gonna add to that now we're gonna go from 1.85 to a really big number. Gonna go as far right as we can go, 0, 1, and we add those two together. So -1 times 10 to the 99, our upper is -1.72. 0 and 1. So normal CDF -1 times 10 to the 99, -1.72, 0, 1. We're going to add to it. Go back to our distribution. Oops. I messed that up. Don't do what I did. Plus. Go back to our normal distribution. Now my lower limit's 1.85. My upper is 1 times 10 to the 99. .0748728978.
I just did that problem that's on the homework today, and I put the answer in it, and it told me it was wrong.
Oh, speak up a little bit.
I did that on a question I just did on the homework, and it said it was wrong.
Okay, we'll look at that after class. Keep it up, and we'll look at it. We'll see what I did wrong. Okay, now everything we've talked about thus far, we are standardizing our normal distribution. So we're looking at the standard normal distribution, and every normal distribution can be standardized. Now, the reason we used to do this is because all we had to find probabilities were z-tables. So we had to take our normal distribution and standardize it so I could use a table to figure out the probability. Well, guess what? You have a calculator that doesn't need to be standardized. You can put the mean of your distribution and the standard deviation of your distribution in your calculator, and it will find the probability. It will find the area under the curve. So you can use the normal distribution with this calculator without having to standardize. Okay, so on your calculator finds areas to the left. It'll find areas to the right, because your calculator just needs a lower limit and an upper limit. But as a reminder, the total area under the standard, the total area under the normal curve is 1. So if you find the area to the left of a particular X value, the area to the right is just 1 minus that. So if this represents the probability that X is less than some value X, over here, this area is represented by 1 minus the probability that X is less than some X, because the total area under the curve has to equal 1. And in between, again, your calculator can find the area in between two values. This would be your lower limit, and this would be your upper limit. And everybody's calculator does that, right? Everybody in here, when you go to your normal distribution, it has a lower and an upper limit. Okay, nobody has a TI-83? We're all good? Okay. Because if you have a TI 83, you gotta change your strategy. Because the TI 83 only finds areas to the left. That's all it finds. It's just like a table. It does not find the area in between any two X values. It only finds the area to the left. So you gotta change your strategy a little bit if you have a TI 83. Okay? All right. So let's use our calculator to find some probabilities. The final exam scores in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Find the probability that a randomly selected student scored more than 65 on the exam. So you want the probability that your X value is greater than 65. I just randomly select a student and their score is higher than 65. If the mean is 3 and the standard deviation is 5, what's the probability of randomly selecting a student whose score is greater than 65? So this is the probability that X is greater than 65. With mean of 63 and standard deviation of 5. So this is a normal CEF whose lower limit is 65, whose upper limit is a really big number, and whose mean is 63, and whose standard deviation is 5. Normal distribution, mean of 63, standard deviation of 5. What's the probability that I randomly select mean of 63, standard deviation of 5? What's the probability of randomly selecting a student whose score is higher than 65? Okay, so we're going to go to our distributions. Number 2 is our normal. My lower limit now is what? 65. My upper limit, I'm going to make a really big number. That works just fine. My mean is 63. So now we're not talking about the standard normal distribution. We're just talking about a normal distribution. So I have to put in my mean and standard deviation, which is 63 and 5. Are we good? And then we paste that back in. So normal CDF from 65 to the right, mean of 63, standard deviation of 5. So the probability is what? 0.34458. Depending on how many decimal places they want you to carry it out to. Historically, what you would have to do is you would have to standardize this. So you would have to find the Z-score that corresponds to 65. The Z-score that corresponds to 65, you take the 65, you subtract the mean, divide by the standard deviation, and you get 0.4. In the area to the right of 0.4 in the standard normal distribution would be 1 minus the probability that Z is less than 0.4. So historically, this is the way you had to do it. And you look this up, this right here, you looked up in the table. But your calculator, you don't have to do this. So you can find any probability, any area under the curve of the standard normal, of the normal distribution using your calculator. I keep wanting to say standard normal. It doesn't have to be standard, it's any normal distribution. All right. Find the percentile for a student scoring 65 out of 100 with a mean of 63 and a standard deviation of 5. Now, what's a percentile? Do you remember? So my mean is 63. My standard deviation is 5. What is the percentile that corresponds to a score of 65? Well, a percentile is that point where you have that percentage scoring less than 65. So the percentile which I can spell, is the number or the percentile that score less. So the percentile would be this area under the curve. So what's the probability that someone scores less than 65? Well, that would be the percentile of that score 65. So we're looking for the probability that someone scores less than 65. Now I figured bigger than 65, right? So less than 65 is 1 minus that. Or you can use your calculator. It's a normal. Now my lower limit is a really small number. My upper limit 65. My mean is 63. My standard deviation is 5. So we're going to go to our normal distribution. My lower limit is a really small number, -1 times 10 to the 99. My upper limit is the 65. My mean is 63. My standard deviation is 5. So I should be about 0.66, 0.655. So these two numbers should add up to 1. The probability that we get a value less than 65 and the probability that we get a value greater than 65, the sum of those two should be 1. Okay, so on our calculator, normal CDF -1 times 10 to the 99, 65.635. And find the probability. I guess I should have written that correctly. The percentile for 65 is around 66. So the score of 65 is the 66th percentile. They're just kind of coincidentally close in value. But the score 65 is the 66th percentile. All right. Find the probability that a randomly selected student scored less than 85 with a mean of 63 and a standard deviation of 5. So our same distribution, normal distribution with a mean of 63 and a standard deviation of 5. What's the probability that I randomly select a student who scores less than 65? 85, excuse me. So this is the probability that someone scores less than 85. So this is a normal. Lower limit would be a really small number. Upper limit is 85. Mean is 63. Standard deviation is 5. So normal CDF. Lower limit is -1 times 10 to the 99. Upper limit is going to be 85. So we just need to change that one number. And the rest are good to go. %, basically. With that mean and that standard deviation, just about everybody scored below 85. And again, why is it almost 1? Because with that mean and that standard deviation being kind of large for this, then just practically everybody scored less than 85. Because the mean is kind of low, 63 is a little low. Standard deviation is 5, that seems a little high. So you are going to have most everyone score less than 85. Find the 90th percentile. Ooh, now what? Find the 90th percentile. That is, find the score K that has 90% of the scores below K and 10% of the scores above K with a mean of 63 and a standard deviation of 5. So when they give you the percentile, that is the area. So if I have a normal distribution with mean of 63, standard deviation of 5, what is this score here where I have an area to the left of it of 90%? So now we're going to use an inverse normal. If they give me the area or the probability, I use an inverse normal. So if I'm given the area or the percentile or the probability, and I'm finding an X, then I use inverse normal. So this is going to be inverse norm. And I actually never remember this one. So I'm going to go second distribution, number 3. Okay, the area is 0.9. The mean is 63. And the standard deviation is 5. So the area is 0.9. Standard deviation, mean is 63. Standard deviation is 5. So inverse norm 0.9, 63, 5. So 69.4. So 90% score below a 69.4. Which means either the final was too hard or they didn't study very well. One or the other. Suppose that the average number of hours a household personal computer is used for entertainment is 2 hours per day. Assume the times for entertainment are normally distributed and the standard deviation for the times is half an hour. Find the probability that a household personal computer is used for entertainment between 1.8 and 2.75 hours per day. So normally distributed with a mean of 2 and a standard deviation of 0.5. And we want to find the probability that if we randomly select a household, they're going to use their computer between 1.8, so 1.8 would be to the left of 2, and 2.75. So that would be to the right. So we're looking for this area under the curve. So we're looking for the probability that our value X is between 1.8 and 2.75. And these are the easiest to find using your calculator. So this is going to be a normal distribution whose lower limit is 1.8 and whose upper limit is 2.75 and whose mean is 2 and whose standard deviation is 5. So what is the area under the curve between 1.8 and 2.75 if the mean is 2 and the standard deviation is 0.5? Okay, my lower limit is 1.8. My upper limit is 2.75. The mean of this normal distribution is 2. The standard deviation of this normal distribution is 0.5. So normal CDF 1.8, 2.75, 2.5. So the probability that I randomly select a household and they use their computer for personal stuff is 0.5886 for entertainment. So you could equate this to a percentage. So if this is normally distributed with a mean of 2 and a standard deviation of 0.5, approximately 59% of households use their personal computer for entertainment. My personal computer is never used for entertainment. My iPad, on the other hand, would be way up there. I use my iPad for work too, because every time I send you a note, either via email or in my OpenMath, if I attach a note, I do all that on my iPad. All right, suppose the average number of hours a household personal computer is used for entertainment is 2 hours per day. Assume the standard deviation is 0.5. Find the maximum number of hours a day that the bottom quartile, oh no, quartiles, or as my husband says, quartiles, quartile of households use a personal computer. He's probably correct in the pronunciation because he's a statistics guy. What's that mean? It's been a while. If you remember, quartiles break our data into quarters. So the median mode of a normal distribution is the second quartile. And again, the second quartile separates our data into 2 halves. So to the left of the mean should be 50% of your data. To the right of your mean should be 50% of your data. So where is the first quartile? Well, the first quartile is right here. And the third quartile is right here. And the first quartile is that value for which 25% of your data is below it. The third quartile would be 75% of your data is below it. So you're looking for the X value for which the area under the curve is 25%, 0.25. That's what the first quartile is going to be. So the first quartile, so since I'm given an area, I'm given a probability, then I'm going to use inverse normal. So if they're having me look for an X value for a given area under the curve or a probability or whatever, and they are giving me a probability because that's what the first quartile does. It breaks my data into quarters. So 25%, the area under the curve is 0.25. So this is an inverse normal with the area under the curve being 0.25, my mean being 2, and my standard deviation being 0.5. I think it's 0.5, not a quarter. So we go second, variables, distributions. Number 3 is inverse normal. The area under the curve is 25%, 0.25, with a mean of 2 and a standard deviation of 0.5. Inverse normal, 0.25 to 0.5. 1.66. $1.6628. So the value 1.6628 hours is the first quartile. Approximately 25% of my users are going to use their personal computer for entertainment 25% of the time. So that is my first quartile. In the United States, the ages of 13 to 55 plus of smartphone users approximately follow a normal distribution with approximate mean and standard deviation of 36.9 years and 13.9 years, respectively. Find the 80th percentile of this distribution and interpret it as a complete sentence. So I have to draw a picture. That's the way my brain works. Normal distribution with a mean of 36.9 and a standard deviation of 13.9. And we're looking for the 80th percentile. So we're looking for that X value for which 80% of my ages are below that. So I'm looking for an age, X, where 80% of my users are below that age. So 80% of them are below that age. That's the 80th percentile. So this is an inverse normal because they give me the area under the curve. They say the 80th percentile, I want to find the X value for that. So that is the area under the curve. So the area is 0.8. So we're going to find our X value is inverse normal. The area under the curve is 0.8. Our mean is 36.9 and our standard deviation is 13.9, which I gave it away. So inverse normal, 0.8, 36.9, 13.9. So approximately 48.5. So let's do that. So the area under the curve is 80%. The mean is 36.9. Standard deviation is 13.9. Inverse normal 0.8, 36.9, 13.9. So 48.6. So 80% of smartphone users are below the age of 49, according to this distribution. Question? Spring break, right? All right, so go get this done and then take your spring break off. You only got a few problems left, right? Wait a minute. Yeah, we're done, right? Let's do today.
There's something new today.
It's 6/2, it's due. When's 6/2 due? Friday?
Yeah.
Go get it done. And then be done with it. Have a good spring break. And I'll see you Monday after spring break, whatever day that is. 21st.